wrong. Let's head over to Bryan Norcross, our very own Bryan Norcross, in studio with us. And the great part about this, Bryan, is you are actually going to be hosting a show later on tonight at 8 o'clock with our very own Bob Van Dillen as well. Hurricane HQ+A. You do not want to miss it. Bryan, thanks for joining us this afternoon.
It's great to be here, Bayne. Yeah, I'm looking forward to tonight at 8 o'clock. We're taking your questions. We did it last year. It was a lot of fun, and we get some really amazing and great questions.
I know our viewers are so interested in everything, and they always want to hear from you, Bryan. You know best. So for a little bit of a sneak preview into what's to come later on this evening, we have a couple of those viewer questions right now. So are you ready, Bryan?
Yeah, ready.
All righty, let's do it. They're really good ones. Nina asks, why is the eye of the hurricane the one most talked about and not any other attribute of the hurricane?
Well, a couple of reasons. One is because the way the hurricane spins to the right of the eye, it's pushing water in front of it. To the right of the eye. To the left of the eye, it's pulling the water the other way, like the Gulf water or the ocean water. So the concern for storm surge is to the right of that center point. So we want to know where that center point is. That Milton was an example of that. When Milton was heading in the direction of Tampa Bay, if it had gone just a little bit farther north, water would have gone into Tampa Bay. Since it went a little bit to the south, water came out of Tampa Bay. So that center point is very, very critical. Besides that, right around the eye and the eye wall is where the strongest winds are. And that's, of course, good to know if you're going to be in the strongest winds or outside the strongest winds. But the big defining thing is that direction of wind on the track where the water is being pushed toward the coast.
I mean, yes, there are other main attributes to a hurricane, but that is probably one of the most impactful
That's
parts
why we follow that center line, because of that water going toward the coast.
That's a great point. Absolutely. Now, next up, we have a question from Kendra. And she asks, Bryan, when African dust caps the Gulf at 5,000 to 15,000 feet, what does a tropical wave need to do to finally break through that?
Well, the dust is dry air. It's coming from the desert. That's why it's called Saharan dust. And the tropical systems don't like dry air. So there you can see it on the satellite. It's that brownish color there. And it's forecast, as we look ahead, it's forecast to spread on across the Atlantic and makes the skies milky and so forth. Well, tropical systems, one of the main ingredients is moisture that they need in the mid-levels of the atmosphere. This is dryness in the mid-levels of the atmosphere. So sometimes you get just enough of inflow at the bottom and enough moisture lifting to break through that and moisten the atmosphere enough that something can form. But it is really a deterrent to storms forming, and it's one of the reasons that we don't have storms way out in the Atlantic this time of year. The other reason is the Atlantic is cooler way out in the Atlantic toward Africa this time of year. But the dust actually kind of shields the Atlantic too. So it helps it stay cooler longer when we have a lot of dust. So the dust season usually goes into July and then starts to fade a little bit, but then is gone by the middle of August.
Right.
And that's when we look for systems coming off of Africa to really light up.
That's when the main development region really starts to wake up a little bit more here, Bryan. Now, another question from one of our viewers, Ryan. He asks, why does Florida's Gulf Coast seem to have more frequent hurricanes than its Atlantic coast recently?
Well, that's a very good question, and we don't really know. But here's what we do know, is that hurricanes come in clumps. So if you look at maps going back into the past and say, okay, let's look at a period of time when, for instance, hurricanes really affected Florida a lot. Well, in the 20s, so this is more recent here, and you look at them all going into the Gulf. We all know about that, right? And that's been over the last 15 years or so, or 25 years since the year 2000. Well, if you go back farther in time, and you look from the, say, mid-20s to 1950 or so, 1950, well, then it's all Florida.
Right.
You had 5 Category 4 hurricanes in 6 years in the late 40s, all hitting South Florida. And if you look in the 50s, 1953, 54, 55, and 60, they were all in the Northeast. there's this clumping in the Northeast. Not every storm, but there was this clumping in the Northeast. So there you can see on the map right there. So Mother Nature does that, kind of gets in a rut. It's why we have droughts, because there's in some places, because it's an extended period where the weather pattern doesn't change. We've been, or we have been, now whether we still are or not, it's an open question, we don't know, in a pattern where just generally speaking, more storms were steering toward the Gulf of Mexico. Last year, not. Let's see what happens this year. We don't know.
We'll have to wait and see. That was a really good question. That was a really good answer there, Bryan. But another one, this is our last question. This is from Daryl. During the start of a tropical depression that eventually turns into a hurricane and it continues to explode to a large weather event, what is the procedures taken by NOAA to decide or to know how big the event is going to be and help keep people warned? What does that look like?
Well, the biggest piece of evidence we have are computer models. And as we've seen, they get just bigger and better every year, bigger in the sense that we put more computer power behind them. And now, last year, the Google DeepMind model showed us that the AI models really can contribute to our understanding. And they've just gotten better and better at forecasting the size of storms, besides the intensity of storms. So that's our best evidence. But the fact is, whenever a hurricane is coming toward the coast, especially toward a populated area, and now almost the entire coast is populated, it has the potential to be a big disaster. So NOAA deploys all the resources available to monitor the atmosphere, put the best information in the computer models to get the best forecasts, and produces the full set of information every time there's any kind of threat to land. That's the protocol, and that's the procedure.
Wow, fascinating stuff. And you know what, Bryan, I know you're going to be busy all night answering tons of your questions. So thank you again for jumping on with us for a little bit here. We appreciate your time, Bryan.
All right, Bayne. Looking forward to it tonight, 8 o'clock.
Yeah, it's going to be awesome. 8 o'clock. You do not want to miss it with Bob Van Dillen as well. HQ&A right here on Fox Weather.